What if the internet wasn't humanity's first great network? We often think of fiber optic cables, satellites, and wireless signals as the peak of human connectivity. But the truth is, long before computers, electricity, or even the concept of instant messaging, our ancestors built vast, intricate, and surprisingly efficient systems to share information across great distances. These systems were not only functional, they were ingenious, relying on ingenuity, intuition, and sheer determination to overcome the limits of their time. From empires that moved messages across continents in days, to birds that carried critical intelligence across mountains, to towers flashing coded lights visible for miles, humanity has always been wired for connection. Each system evolved to meet the needs of its society, adapted to geography, resources, and the urgency of the messages being sent. Today, we're going to explore the forgotten networks of the past, the internet before the internet, and see how humanity mastered the art of communication long before modern technology existed. Along the way, we'll uncover surprising lessons about efficiency, creativity, and the enduring desire to connect across distance. Imagine standing on a hill thousands of years ago, looking out across a vast landscape. Smoke rises in precise patterns from distant valleys, or the rhythm of drums echoes across the hills. These weren't random signals. They were deliberate messages, crafted with care and meant to be understood by those trained to interpret them. Many indigenous peoples across Africa, the Americas, and Asia developed sophisticated drum languages and smoke signals to communicate across vast distances. Each beat, each puff of smoke represented a distinct meaning, warning of danger, announcing the arrival of visitors, or calling people to assemble for important decisions. These early methods were primitive by modern standards, but they demonstrated a remarkable understanding of timing, clarity, and redundancy. They were early forms of data transmission, laying the groundwork for more complex communication networks. The Greeks, too, developed remarkable systems. Fire beacons placed on hilltops were used to warn of invasions, and the signal could travel from one end of the territory to another in hours, a speed unmatched by messengers on foot. Imagine standing at the top of a mountain, watching the flicker of flames in the distance, knowing that each movement represents life or death information. It was the first real broadcast system, and its effectiveness depended entirely on precision and training. Even in small communities, protocols emerged. People learned to interpret the rhythm of a drum or the shape of a smoke column as codes. These protocols ensured that the message sent was the message received, a principle that remains at the core of modern networking today. These systems remind us that the desire to share information quickly, securely, and reliably is as old as humanity itself. Consider this: every puff of smoke or drumbeat was not merely a signal. It was a reflection of the ingenuity required to solve a problem we now take for granted: how to communicate across distance. And while the technology was simple, the concept of encoding, transmitting, and decoding information was already being practiced centuries before anyone imagined the internet. Fast forward to one of the largest empires the world has ever seen, Rome. To govern vast territories, the Romans relied not just on armies and roads, but on a sophisticated communication system known as the cursus publicus. This was not a casual network, it was a fully organized postal system, with relay stations, fresh horses, and couriers trained to deliver messages swiftly and accurately. Officials could send letters from the heart of Rome to the empire's farthest reaches in just a few days. Compare that to the months it might take for a letter to travel across Europe before the Roman road system. This network was revolutionary. Imagine a letter moving along winding roads, passing through relay stations where couriers swapped exhausted horses for fresh ones. Each station functioned like a node in a modern network, ensuring the smooth flow of information. The roads themselves were the cables, the couriers, the packets, and the relay stations, the routers. It was an analog internet constructed entirely of human effort and ingenuity. The cursus publicus allowed emperors to command armies, governors to report civil matters, and merchants to conduct trade with remarkable efficiency. Cities flourished, and conflicts could be managed with information that arrived swiftly enough to change outcomes. The success of Rome's communication system demonstrates a timeless principle. The speed and reliability of information can determine the fate of entire civilizations. Moreover, the Romans understood the importance of redundancy. If one route was blocked or a courier delayed, alternative paths and backup riders ensured that critical messages still reached their destination. It's a lesson that echoes in modern network design, where backup systems prevent failures from causing chaos. This network also fostered innovation in record-keeping and bureaucracy. Messages were often written in shorthand, with codes and symbols to save time and reduce error. In many ways, the Romans anticipated modern concepts of compression and encryption, centuries before digital technology existed. Their achievements remind us that the drive to communicate efficiently is universal, shaping societies and empires in ways we still rely on today. Several centuries later, humans found a surprising new solution: carrier pigeons. These birds, trained to return home over great distances, became indispensable to communication in both peace and war. Armies used pigeons to send critical intelligence, while merchants transmitted market prices and trade information across cities. Even into the 20th century, pigeons played key roles during both world wars, carrying messages that could mean life or death. Their reliability, speed, and natural homing ability made them the wireless drones of their time. Silent, efficient, and remarkably effective. But pigeons were not the only innovation. In China, networks of watchtowers relayed smoke and fire signals across vast empires. Greek beacon chains carried messages over mountains, and European medieval cities developed elaborate bell systems to coordinate defense and warn of attacks. Each of these methods had limitations, requiring brevity and simplicity. Most messages were reduced to essential signals: yes, no, danger. But collectively, these systems created robust and resilient networks. Imagine the logistics involved. Operators at each tower needed to understand codes perfectly. Timing had to be exact, and messages had to travel continuously without interruption. Errors could mean missed warnings, failed trade, or even disaster in wartime. These systems required discipline, training, and redundancy. principles that remain central to modern communication networks today. In addition, these methods inspired creativity. For example, some medieval European cities painted symbols on towers or used patterned drum beats to encode messages with layers of meaning. Operators learned to anticipate signal degradation and adapt messages for clarity, much like engineers do today when dealing with packet loss or bandwidth limits. These lessons show that communication is not just about technology. It's about human problem-solving, adaptation, and ingenuity. By the late 18th century, humanity took a decisive leap toward networks resembling our modern internet. In France, engineer Claude Schep developed the optical telegraph, a network of towers with mechanical arms that could be moved into different positions. Each position represented a letter, number, or symbol, and operators used telescopes to read the signals from miles away. Messages traveled from tower to tower across the countryside. A message that once took days to deliver by horse could now arrive in hours. At its peak, France built thousands of these towers, forming the fastest communication system in Europe. The operation required precision, timing, and skilled operators, a testament to the importance of training and standardization in communication networks. When Samuel Morse introduced the electric telegraph in the 1830s, he was building on centuries of accumulated knowledge. The idea was simple in theory: turn language into code, transmit it across distance, and be coded at the other end. Yet implementing it required rigorous attention to detail, redundancy, and foresight, the very same principles that had governed smoke signals, Roman couriers, and pigeon networks. This period also saw the beginning of real-time communication. Messages no longer moved at the pace of human or animal endurance. They could be transmitted almost instantaneously across vast distances. For the first time in history, information traveled faster than people could physically move, fundamentally changing commerce, diplomacy, and warfare. It's fascinating to consider that the challenges faced by early telegraph engineers, error correction, code efficiency, and signal clarity, mirror the problems we solve today in digital networking. The optical telegraph reminds us that technology evolves not in isolation, but as a continuation of human ingenuity over millennia. Looking back, the internet did not appear out of nowhere. Humanity has always sought ways to connect, to shrink distance, and to share knowledge faster. Smoke signals, Roman post, pigeons, optical towers, each was a stepping stone solving similar problems in its own context. Each network rehearsed the same principles we rely on today: speed, reliability, redundancy, and clarity. They taught humans how to coordinate complex systems, how to encode and decode information, and how to maintain trust in the message being delivered. Innovation, as these examples show, is rarely sudden. It is cumulative, iterative, and often surprising. Next time you open a browser, send an email, or stream a video, remember that you are participating in a story that began thousands of years ago. A story of ingenuity, creativity, and the endless human desire to connect, adapt, and share knowledge. Archivist Tech, where curiosity shapes the future.